Hello, hello. Welcome, everyone. Thanks for coming. I'm really excited about this Twitter space. I guess it's called X Spaces now. We're going to be talking about all things Bitcoin and modularity and rollups. And joining us today, we have Eric Wall from Taproot Wizards, and we also have Orkun from Citrea. And we should have Robin Linus joining us later. I think he's running a little bit late, so hopefully he'll come in due time. But we wanted to get started anyway. So why don't we start out with a bit of an introduction for our guests? Maybe give us a little background about you and why you are passionate about or interested in the topic of Bitcoin rollups and modularity.
Yeah, shall I take it away?
Yes, Nick? Eric.
How are you doing today, by the way, Nick?
Good. I'm so stoked to be on with you.
So it's I think it's super exciting. Like there's two big narratives coming head on here. The first one, and I really think that this is quite incredible, that the data availability. I mean, we've been talking about this for years. Made predictions since 2022 that DA is going to become this big narrative unlock, and that people are going to realize that for this elegant layer 2 construction that are called rollups, the scalability limiter in most cases is bounded by how much DA you have, basically how much data can your system access, because we know like how you generate these fraud proofs and validity proofs comes down to you as a user having access to data, and how secure are you that you're going to be having access to that data in time. Like we've been predicting that DA was going to become like a massive thing, but we didn't really know that was the case until like we've seen how successful the Celestia launch has been. And now like Celestia is here, it's launched, and like everyone's talking about DA. Everyone and their mother is basically launching a DA layer now, and Celestia was the first one to sort of really focus on that. I mean, I remember Celestia since the lazy ledger days. That's sort of how you flex these days, that that Celestia used to be called lazy ledger. That's in-group signal mechanism. And then we have this other narrative that's happening in parallel to this, which is that Bitcoin. I think really what has happened is that Casey Rodarmore found a way to turn arbitrary data into JPEGs on Bitcoin, and that turned out to be a slam dunk success, massive hit. Everyone's doing it. We, of course, with Taproot Wizards, love this idea because the reason that it's so interesting is not necessarily, there's a bunch of interesting things culture-wise that you can do with JPEGs, but the most interesting part here is that when people are fucking around with JPEGs on the mother chain, then it causes fees to go up, and it exposes these realities about the scalability solutions that we thought worked. And the sort of overall sentiment for Bitcoin is probably that people are coming to terms with Lightning doesn't seem to function as well as we thought it would in a high fee environment. When people notice that it's very difficult and challenging and expensive to rebalance your channels when the L1 is congested, and while that is happening in Lightning, and you see these other layer 2 solutions built on Ethereum that don't have this challenge with you don't need to rebalance your rollup because there are no channels in a rollup. It's another type of layer 2 construction that's been completely like unexplored and haven't been like given the time of day in the Bitcoin world. And I think this comes from basically that the Bitcoiners saw how the Ethereum people were how they were embarking on the L2 journey initially. So you'd see white papers like Plasma, and then they never really went anywhere. And you'd see state channel ideas being popularized by the Ethereum world, and then seeing how Raiden, for example, just did an ICO for a token, and then nothing really happened. And I think there was a point where you actually needed to use these Raiden tokens to use the layer 2 solutions, and everything just seemed like it's going nowhere. And then within the Ethereum research community, you of course had people understanding that actually rollups do work, and the problems with these previous layer 2 constructions like Plasma, rollups target their specific pain points, like the reason that they don't work with the max exit problems and the data availability issues, and just has the exact solution to all those challenges. So in the Ethereum community, like since 2018 to 2019, it's been well known that rollups actually do work, but it's taken like until now for the Bitcoin community to, now that we're coming to terms with Lightning not being a solution, you can see that there's like billions of dollars inside these Ethereum L2s, and they obviously did ship, and there's a lot of excitement there. So we have these two things coming together, that Bitcoin is now understanding that there's another way to scale blockchains that we can take lessons from, and that in conjunction with the modular thesis that you can sort of pick and choose your execution environments and your DA layers, and you can compose those together. It doesn't need to be like all that DA that you're looking for to get your scalability solution working doesn't need to come from Bitcoin necessarily, depending on what your trust model appetite looks like. Yeah, so to sort of answer your question, my name is Eric Wall. I work with the Taproot Wizard team, co-founder of Taproot Wizards. I've also been like involved in the Bitcoin space and Ethereum space for a very long time. And what we're talking about here today is sort of a collapse of a bunch of different theses and narratives that are all now here coming into sort of the eye of the what do you call it? The eye of the tornado, the eye of the storm. Right. Yes, I'll leave it there and pass it over to Orkun.
Yeah. Well, that was a wonderful way to open up the space, Eric, because I think you touched on almost like so many of the topics that I want to get into, things like Taproot and the other scaling solutions that Bitcoin has tried in the past, and how they sort of contrast with rollups, as well as like all the other like themes around modularity, like data availability and stuff. So excited to dive deeper into a lot of those things that you mentioned. Orkun, why don't you jump in and give us an intro?
Yeah, sure. Hello again. Hello, everyone. So I'm Orkun. I am the co-founder and CEO of Chainway Labs, the company building Citrea. Citrea is the first ZK rollup on Bitcoin. So, like similar to Eric, I do think the same things with like ordinals. We find a way to embed arbitrary data into Bitcoin. And before ordinals, actually, we were a team working on ZK. But after ordinals, we realized, okay, there is this huge potential that Bitcoin can be used for a base layer for so many applications. Then actually we merged these concepts together and started building the first sovereign ZK rollup on Bitcoin a year ago. And back then, this was a cool idea that you can access all the meta protocols, all the things, but not liquidity, because it was only like pure DA layers. There was no bridge on Bitcoin, and so. And after that, there's this BitVM paper came out from Robin, and 2 or 3 days after we met with Eric, and like he said to me, I remember, I thought that 1 year ago sovereign ZK rollups on Bitcoin was the coolest thing, but right now there's this BitVM stuff, and we wanted to work on that. And I think after a couple of weeks after that, we realized to build a bridge using this BitVM stuff as well. So since then, we are building Bitcoin's first ZK rollup and building on Bitcoin's liquidity and bringing modularity to Bitcoin.
Awesome. Well, we'll also talk about BitVM. I hope Robin does end up joining, because obviously he's the author of the BitVM paper. I feel like that. I think there were a few different moments over the last year that have sort of increasingly sparked more and more interest in Bitcoin rollups. I think BitVM is definitely one of the biggest ones. So why don't we just dive into the fact that, from my perspective, Eric, you touched on this, but the Bitcoin community has been exploring sort of off-chain scaling solutions for a long time. Like, none of this is really new, right? You have ideas like drive chains and Lightning, and I think even in like way back in the day in the Bitcoin forums, a lot of the old OGs were discussing these different novel approaches to scale Bitcoin that look, in a lot of ways they have a lot of similarities to rollups. But so what's different about rollups versus these other approaches, and like why are you guys much more excited about this?
Yeah, I can answer that. So the way that I see it is that basically before zero knowledge proofs sort of became good enough for applications like blockchains, that you could verify zero knowledge proof on your laptop that could prove a complex computation. I mean, you only have to go back a couple of years, and it wasn't the case that zero knowledge proof really were feasible to run on like consumer grade laptops. So you have basically an explosion in innovation in zero knowledge proof and applied cryptography, and you also have just fraud proofs in general that sort of happened almost in the same moment in time. The idea that you could build optimistic rollups using fraud proofs, those are relatively new ideas. Even in the Ethereum world, I mean, these ideas came to the scene 2018, and then also having the full rollup construction where you put all the DA, so you don't get these fisherman attack scenarios where you can't access the DA and you run into issues where like an operator freezes and you can't unilaterally access your funds. I mean, those innovations happened not that long ago. And in the Bitcoin space, we needed to come up with scalability roadmaps before that. So like in 2015, that's when the block size wars and the scalability wars started in Bitcoin. And then Bitcoin needed to come up with a scalability narrative, like how are we actually going to scale the system? And back in 2015, it wasn't that we could say, oh, we're just going to do fraud proofs and rollups, and then that's how we're going to scale it, because that solution didn't exist at that time. And similarly for zero knowledge rollups, that technology was something that had been theorized in Bitcoin forms, but it wasn't ready for consumer grade applications. It wasn't something that you could run on your own laptop. It was mostly just theory at that point. And most of the theory didn't even exist at that point. So Bitcoin had to come up with a scalability narrative, and Bitcoin explicitly, if you sort of think about the elders of Bitcoin, sort of the Greg Maxwell's and Andrew Poelstra and Peter Willis, the authors of SegWit and Taproot, which are our latest two soft forks in Bitcoin. I mean, if you put yourself in the shoes of those people that were supposed to come up with a vision for the future back then, you really didn't have that many options. There were some ideas on how to build channel-based scaling that Satoshi started playing around with payment channels back in 2013, and sorry, 2009, 2010, and then the elders of Bitcoin basically had to decide now, well, do we just want to make the blocks larger and forget this whole idea that you're supposed to be able to validate a Bitcoin block on your own full node, and just makes the blocks bigger, and basically centralize the blockchain validation so that only a few like big mining pools or big corporations could be involved in that activity. I think back then it did make sense for the Bitcoin developers to say, well, considering this option between like channel-based scaling, which is going to be complex, it's going to be hard work, and we don't know if we can work out all the kinks and the quirks of that, or we go and we just make the blocks bigger and we basically undermine the decentralization of the system. If you are now like tasked with like this monetary revolution, like this monetary invention, you're gonna probably choose and say, well, why don't we explore the safer path that doesn't undermine the centralization of the protocol and see if we can get that working. So that's basically what they did. So 2015, 2016, 2017, during those years, this sort of small blocker camp was cemented, and the vision for Bitcoin to scale through channel-based scaling, that was basically the roadmap that was carved out. And then perhaps the accident that happened was that after the block size wars were won by the small blocker side in this war, then you had a very, very effective meme campaign and like a social campaign that needed to convince the rest of the crypto industry and the internally in the Bitcoin space that this path for scaling was going to work and that it was going to be a slam dunk success. And you started to do things like coming up with excuses, and you started to like focus more on like narratives than you actually did on like doing actual technology work. So many of the like when we tied ourselves with them to the mast of this scaling based approach, it also shut down a lot of other conversations that could have happened in the periphery during that time. So to answer your question, the rollup paradigm scaling paradigm didn't exist at the time that Bitcoin was in this sort of phase where it needed to pick a specific scalability path and convince people that the future of Bitcoin was technologically solved and was just now an implementation detail and a market maturity, challenge to get that thing ready. So it wasn't. It hasn't really been until now, when the system is like getting stress tested, that even Lightning developers themselves are looking at this thing and saying, hey, maybe we haven't finished the technology homework here, and maybe there's still frontiers left to be explored.
I see. Yeah. So there was a lot of, I mean, yeah, the big block debate and how all that went down and how that then informed the rest of the scaling roadmap and the attitude towards scaling was really relevant. And then it kind of became clear, I guess, at some point that there were better solutions that had emerged, I guess, elsewhere and were relevant to Bitcoin. And now that's sort of like filtering through. Is that sort of the right way to think about it?
Yeah, I'd say so.
Yeah, I think several other points also besides what Eric said. So the technology was the thing, but back then I think most people were focused on how do we make payments better, and at that time this channel scaling like Lightning should look better to those people, so they started implementing. But especially with the ordinals, we see that people demanding Bitcoin block space, and they mostly demand to do programmable things, not just payments. Obviously, like trades on Orkun marketplaces are payments, but people like want to lend their BTC, lend their Ordinal, or like do this decentralized exchange swaps, and channels are not enough for that. And once people realize that, like our team, we think that okay, channels doesn't solve this. And also like the right chains, they stuck with merge mining, which is like too old idea. And right now we have zero knowledge proofs, which are like way more scalable and applicable to Bitcoin also. And it solves the two-way peg problem. So why not start with these? Yeah, technology was one of the important factors, but others is Bitcoin kind of enabled this Bitcoin economy itself with ordinals. And we realized that we need a fully fledged VMs like EVM or other VMs that you can actually build programs and run and enable this Bitcoin finance, even though it is for just tokens or like NFTs, but the Bitcoin native asset itself also.
Yeah, I think that aside from scalability, I think Bitcoin going modular also seems to be a conversation about what Bitcoin should be used for, right? I think there's sort of like the Bitcoin traditionalists who think that okay, it should only be sovereign money, and any other use case, whether that's ordinals or even rollups on top of Bitcoin are like a plague or a distraction from what people should focus on. So it seems to me that there's also sort of like a cultural element to this about it's not just about scaling Bitcoin, but even adding new functionality and finding new uses for Bitcoin and enabling people in the Bitcoin community to start doing all the other things that people in the Ethereum and the rest of crypto have been doing for a long time, things like DeFi and NFTs and all these other like emerging use cases. How much do you think this is a culture thing beyond just a technology thing?
Yeah, so I think that it's definitely probably mostly a culture thing at this point. I don't know how to explain it. I mean, I know the sequence of events that led us here, but from my perspective, Casey Rodarmore with this little trick using the Taproot upgrade to find a clean way to put in arbitrary data blobs into Bitcoin. It's just like it opened a portal in the Bitcoin culture. Because now that you can put any arbitrary that you want inside of Bitcoin without like splitting it up over multiple inputs or multiple transactions, it just I mean what we did at the Taproot Wizards team was that we took like an entire Bitcoin block and we filled it with one entire 4 megabyte JPEG that filled up an entire Bitcoin block. And that sort of when we did that, this was like one of the first few hundred inscriptions in Bitcoin. But I think like that really like cast. I don't want to give myself too much credit here, but it did like cast a spotlight within the Bitcoin community to the point where like they couldn't stop talking about like these fucking JPEG people are like filling up entire blocks now with JPEGs, and then like they couldn't stop. They got so mad and like they couldn't stop talking about that. So it almost became like a funny thing where it became funny to use this possibility inside the protocol, and regardless of what you did, you could guarantee that the entire Bitcoin maximalist space would be up in their arms and like talking about this and inadvertently like giving a lot of attention and like free marketing for the projects that wanted to engage in that activity. And then when we started to think about, okay, well, so what are we actually doing here? Like, are we just fucking around and trying to make Bitcoin maximalists upset by putting JPEGs on the chain that they can stop? I think that there were some narrative points that actually had authenticity and legitimacy to them. And the idea that, I mean, if you think about like putting a JPEG on chain, like why would someone actually do that? But it's not that stupid if you go back and you look at like old forum posts or old like counterparty NFTs, and most of those NFTs that had like Web2 links, you can't actually fetch those images and see what the JPEG was. So like that part of Bitcoin culture, like when people were doing like these NFTs on Bitcoin before ordinals existed, with counterparty, like we can't really see a lot of that art has just disappeared and it's died. And I think that this is like one aspect of Ethereum NFTs that some people think, it's a bit cheap. Like, yeah, sure, you can put an IPFS link, but IPFS is not like an automatic data replication system. It's just a hash of an image that someone is hosting. So it's not necessarily even more. It doesn't give you better guarantees that necessarily than like a Web2 link does. So there's a bunch of IPFS links that are gone too that don't link anywhere anymore. So if you this narrative that started to emerge within the Bitcoin ordinal space was that, well, if you actually inscribe all that data inside the Bitcoin network, then that JPEG image is always going to be available. And if you have an NFT that for some reason like should be super valuable, maybe it's created by a super famous artist, or it represents a cultural moment in time that it's a symbol for something, why wouldn't you pay like a few $100 or tens of bucks to make sure that data gets embedded into the Bitcoin network? So I think that part of the story, the data availability part, was actually something that gave that part is actually true, that there is a use case for that, and people haven't been doing NFTs in that way. It is true that you can do Ethereum NFTs like that. I know that there are some NFT projects that do put all the necessary data into the state of Ethereum, but at the same time, you have like Ethereum in general. Like if you put, for example, if you wanted to do if you wanted to store your JPEG data in the same way that Rollups, for example, store their data on the Bitcoin, on the Ethereum network, then the roadmap of Ethereum is going towards like history pruning. So if you look at this famous roadmap image by Vitalik, I think in the section called the splurge, you'll see. No, actually, I think it's the purge. You'll see this history expiry thing on the roadmap, which means that the history of the blockchain of Ethereum that's older than 1 year will get purged. Like regular full nodes won't actually store that. So you can't really think of Ethereum as a persistent place to store your data, and that is one thing that Bitcoin has. That the whole design philosophy of Bitcoin is that we're never going to make the blocks bigger than what is possible for a regular person to download on their laptop. So right now the Bitcoin blockchain grows by 200 gigabytes per year, and we're not going to increase that limit, so it's now unfeasible to even download the entirety of the blockchain. We're going to have to stick with like how more ubiquitous is data becoming for regular people and regular users, and then sort of make sure that the block size limit isn't expanded beyond that. So that data that is accessible in Bitcoin, you can actually think of it as a scarce resource. You can think of it like you're taking that scarce resource and you're taking those bytes out of the Bitcoin blockchain that is scarce, and you're molding them into artworks. You're molding them into music files. You're molding them into these things. And I think that innovation or variant of doing NFTs kind of came at a time where NFTs in general were also suffering from, like, the prices were down. It's a bear market. People are looking at their stupid monkey pictures, and they're like, why did I like spend generational wealth on this picture? And so NFTs really needed a new story, a new rebranding, and it just happened. The timing of that just happened, lined up so well with ordinals that Bitcoin has, like, in a very legitimate way, in a serious way, started to like onboard the entire NFT space. Like, I think that an ordinal connection like Node Monks right now is very close to flipping Bored Apes. So you have these new coming Bitcoin projects that are like competing in size and market share with the top Ethereum projects from the last cycle. And I think that also, like, with Bitcoin getting the ETF, Bitcoin growing and becoming more like relevant in society now that there are traditional financial instruments to invest in this, I think that a lot of people are thinking like, why aren't I building on Bitcoin? Why am I not putting my project on the mother chain if it is possible? Like, why would you go for number two when the number one provides you with that access? So I think that is a big story, like a big part of why this is happening now on Bitcoin.
Absolutely. Orkun, do you have any thoughts?
No, not specifically. I think I said already, but I generally agree with Eric's point. Yeah.
Yeah, I think at least for me, seeing the ever since kind of ordinals came on the scene, I kind of had discounted Bitcoin, I guess, from a technological perspective, and really wasn't paying attention. And I thought, all the innovation is going to be happening elsewhere. I mean, obviously, I still believed in Bitcoin sort of as digital gold and just sovereign like money, but ever since ordinals and sort of the pickup of innovation in Bitcoin, all of a sudden I'm like, wow, actually, this is really interesting. And so what I'm trying to say is, I think that modularity and starting to use Bitcoin in different ways is also attracting new community members. It's not just sort of converting the existing one. It's also like drawing other people closer and making Bitcoin more interesting. So anyway, I think I want to transition a little bit more to the technology aspect of this, because when I talk about Bitcoin rollups with some people, they kind of discount it, saying that, or at least the existing rollups, because they say, well, how much are these L2s or rollups actually rollups when Bitcoin has very little DA throughput. It's really the wagyu of DA options because it's so scarce. And it also has no settlement capabilities, at least not yet. I mean, obviously, BitVM sort of showed a way to make this possible, but as far as I know, it's not yet live, especially not with any of the existing rollups. So like, to what extent are these existing rollups real, and what is the roadmap, or what technology, what does Bitcoin need to do in order to make itself more, I guess, suitable for make itself more modular, essentially, to support these new emerging use cases?
I think like the rollups on Bitcoin, like to be honest, most of the teams that markets like their product as rollups today, they are not building rollup, they are building side chains. But this is like a hot word, so they are using it and like raising money and ICO and stuff. So I'm skipping that, but in a technical sense, rollup is a blockchain that uses the underlying blockchain's data availability and consensus. So even though it's like a sovereign ZK rollup on Bitcoin or uses BitVM or uses any other mechanism, I think we can call them real rollups. Yes, the DA is very limited, but this doesn't affect the abilities, and settlement is not a, let's say, prerequisite for being a rollup. But yeah, what we actually know about rollups is they kind of have this trust minimized or trustless breach between the base layer. This is still missing today. BitVM is completing this part in a way that like BitVM is very generic virtual machine that you can build anything, but most of the teams will build bridges, including us, and right now we are working on it. So it will enable this Bitcoin settlement in an optimistic way, similar to what like Arbitrum runs on Ethereum today. So it will also enable settlement so that we will have this trust minimized two-way peg. So I will say, yeah, if the product is actually exists, then Bitcoin rollups are real.
I think that we're currently existing in this terminology hell, and I don't know. I don't.
That's definitely correct. Yeah.
Yeah. So let's talk about this terminology hell. Why it is so confusing, and I don't know. I don't know how we got into this situation. I don't know who to blame. I'm wondering if I helped cause this terminology hell myself, and now I'm sitting in this bed. But what basically I think probably the most problematic term that we have is the idea of a sovereign rollup. I think a sovereign rollup was, I mean, I think it started to sort of blow up when people were thinking about the various forms of Celestia rollups. And you have this idea of a sovereign rollup. And in the Celestia context, it makes a lot of sense because with a sovereign rollup, it means that the execution logic of your chain can be an independent social community that can fork and change what is the underlying consensus of this network, while you still have a more global consensus on the ordering of the data. So you can hard fork, you can soft fork, irrespective of what other rollups are doing. So you have this very well defined category that's called a sovereign rollup. It makes sense, right? But if you take that idea now and you say, I'm going to build a sovereign rollup on Bitcoin using this block space that we just talked about that people were making JPEGs out of, and you say, well, I'm just going to take that data and I'm going to make a sovereign rollup on Bitcoin. So doing that can potentially be a very cool idea, because you can get a lot of the security benefits of Bitcoin in terms of its data availability and its ordering. You can take that and you can create a strong, but as you say, very limited a roll up, and you can build that on Bitcoin. And now, yes, you cannot. The main constraint here is that you cannot bridge the Bitcoin asset into that sovereign rollup in a trustless way. But we can see that in the ordinal space, there are a lot of people that are making new assets, right? So they're making ordinals, NFTs. They're making BRC20 tokens, like semi-fungible tokens and fungible token standards. And that is turning into its own ecosystem. And if you want to do that on Bitcoin, why don't you actually put it into a better execution environment? Like you could put, for example, the EVM there, but you could also put other VMs like the Cairo VM. So you could access this tooling and infrastructure that has already been developed and built, and just use Bitcoin as a DA layer, and then you can plug on any execution environment that you want. Okay, so that sovereign rollup idea now makes sense. But when you're now thinking about sovereign rollups in this way on Bitcoin, you also realize that, wait, if this is the terminology that we use, there's a bunch of things that actually classify as sovereign rollups on Bitcoin. The most common examples that people will bring up is Mastercoin. So some people might not know it, but Tether USDT used to be like all the USDT stable coins actually used to be existing on Bitcoin using something called the Omni layer, and the Omni layer did exactly this. It embedded a bunch of arbitrary data into Bitcoin transactions, and you had another system, another client that you double clicked and it ran and it interpreted the Bitcoin blockchain in a different way than what a Bitcoin core node would do. So you gave it other semantics, other rules, other meaning. You took that data and you created other meaning out of it. It still inherited a lot of parts from sort of the normal Bitcoin stack, like how do you transfer an asset? What is a valid? How does a valid transaction look like? It reused much of the UTXO model of Bitcoin and like how keys work, but it basically created a fungible token standard protocol on top of Bitcoin, and a non-fungible token standard as well. So you had NFTs, and so the Omni layer was basically this, right? A way to have other tokens on top of Bitcoin. And using the terminology that we have today, a sovereign rollup, the Omni layer was exactly that, right? And then there are other systems that we would also call sovereign rollups on Bitcoin today. Actually, ordinals themselves, that's also the ORD client would also classify as a sovereign rollup on top of Bitcoin. And inside of ORD, there's this BRC20 protocol that describes how you can use the ordinal protocol to create JSON files that describe how a specific, like it would describe a specific semi-fungible token inside the ordinals protocol. That BRC20 protocol that runs on top of the ordinals protocol is also a sovereign rollup on Bitcoin. But even though this is potentially confusing, it is also 100% legitimate that sovereign rollups and sovereign ZK rollups, if you do exactly what OmniLayer did, or what Mastercoin or what BRC20s are trying to do, if you do exactly that, but instead of having, one of the issues, for example, with the BRC20 standard right now is that it's actually extremely difficult for a regular person to run a BRC20 node and figure out who has which token balance, because it uses this incredibly inefficient way to index the data inside the ordinal system to create like different accounts and balances and keeping track of who owns what. It's super complex. So if you instead had a very elegant account model and you had a zero knowledge proof, then you could build a very efficient system to keep track of who is transferring which tokens, and so you can build very competitive protocols, sovereign protocols inside of Bitcoin using the modern technology and ZK circuits. And this is basically, I think, yeah, Orkun, I'm going to pass over the ball to you here, but this is basically the starting point for Citrea and the Chainway team, right? Let's just build much better execution environments on top of Bitcoin using the EVM and zero knowledge proving that, using the best-in-class proving systems and risk zero and graph 16 ZK circuits. So that is a completely real thing, and according to the known terminology frameworks that we use in crypto, this would be a sovereign ZK rollup. So that is a very real thing that exists, and it's a cool thing, and people should absolutely explore that design space. Now, the difficult thing that has happened now is that meanwhile you can have a sovereign rollup, ZK rollup if you want. There's now this new invention that Orkun talked about, which is BitVM. And BitVM is a way to build an optimistic two-way peg for the Bitcoin asset to sort of get locked in a contract on the main chain and then unlock in the sidechain environment. And then since it's a two-way peg, it also means that you can bring it back from the sidechain to the main chain. And the validity of these transfers, BitVM is the contract and the code that actually runs using the Bitcoin script itself, the layer one scripting tools. And if I need to explain like what BitVM is for someone that maybe is new to this idea, the way that I would describe it, and bear with me because this is the first time that I'm trying out this explanation, so we'll see how it works.
You can do it, Eric. We believe in you.
So imagine that you have a chessboard and you're trying to use the different pieces on the chessboard. You have a knight, you have a horse, and you have these pieces on the chessboards. They have these predefined ways that you can move, right? So for example, that you have a pawn. You can only move crossways or forward, or you can do like these two-step jumps. If you're thinking that I'm going to use this chessboard logic and I'm going to create a computer out of it, I'm going to create a Turing complete computer out of the pieces of the chessboard by like inventing a game for how the pieces can move, but you're only working with the knights and the pawns and the bishops on the chessboard and using their the way that they can move around. That's going to become, you're going to run into some clunkiness reaching a Turing complete stage using these tools at your disposal if you're trying to do that with a chessboard. BitVM basically says, well, forget all the pieces that are on the chessboard. Let's remove all of them and let's just use the pawns, because the pawns have this sort of binary aspect to them where they can only move forward or sideways. And if you think about a computer at its lowest instruction or its lowest computational ability, you basically have a logic gate that can take a 0 and a 1 and decide if the output should be a 1 or a 0. So you have basically like two incoming numbers, and then you're supposed to say, okay, so I have a 0 and a 0. Should the output be a 0 or a 1? That's what logic gates do, and that's what like the smallest component of a computer ultimately does. Like we have these transistors, and they do these extremely simple things. But if you just put on more layers and more context, you can actually reach a Turing complete computer at the end of it. So BitVM focus on this concept called NAND gates, and because Bitcoin has the ability to do a NAND gate computation, if you then apply the sort of the power of taproot trees and use these NAND gates that you can actually emulate through Bitcoin script, then you can build a Turing complete computer inside of Bitcoin. If you sort of if the only thing that you're trying to do is prove that a computation was not executed correctly. So it basically tries to build a computer out of like white and black pebbles, and it uses bisection games. It uses logic gates essentially to prove that some type of computation was not executed correctly. So it carries some resemblance to how optimistic rollups work. It just does that at a much more primitive level. And that also means that it's much more complex to work with, because you cannot invalidate a state transition with like the full semantics of an EVM. You have to do it at this super, super low level where you're like checking, like, did this 0 turn into a 0 when it should have turned into a 1? So that is sort of my high-level description of what BitVM is. I'm sure that I sort of fucked the explanation up. I'd love for you, Orkun, to sort of attack that description and like how you reason about that system. But the unlock here is that you're actually tapping into a Turing complete computation on Bitcoin, even if it requires like lots of. The main trade-off here is that this game can only really be executed among the participants in the game. So imagine that this whole thing is like a state channel, and that dispute resolution game can only be played by the people that are in that state channel. That is basically what you can do with BitVM. So it allows you to build a type of two-way peg for Bitcoin, but it's not going to be accessible to anyone in the way that rollups are. So, for example, in an optimistic rollup, anyone can or is supposed to be able to deposit a bond and make a fraud proof. and say that this state transition in the rollup, I'm gonna post a fraud proof here. I'm gonna show to the rest of the rollup participants that a computation, a state update happened incorrectly in the rollup. That is not possible in the BitVM paradigm because it's only accessible to the participants in a specific state channel. So that will be like a predefined multi-sig of participants that now has the ability to play out a verification challenge game between each other. So we have some like flavor of optimistic rollup. It's just that it's confined, that it's not something that can be unilaterally accessed by outside participants that are observing this game. I'm going to pass that over to you, Orkun, if you want to sort of brush up that analogy in some way.
Yeah, I think like most of your explanation was correct. I expect the one thing that is like get updated in BitVM implementation, but yeah, very simply, there is this off-chain computer, literally a computer running among a set of participants, and if any of them doesn't agree with the results, then it can go on-chain and force the computer to reveal some points, very succinct points, so that it can make the claim incorrect or correct in terms of Bitcoin's point of view. So this is a very simple explanation. But besides, like you mentioned about NAND gates and like one or zeros, the current BitVM implementation, instead of depending NAND gates, it really depends on instructions, like a computer instructions: add, multiply, divide, module, like that. And thanks to that, right now the trace length is much more smaller, which allows us to do much more with that. So this is the one update that I will add. And the bridge part. So people usually think that, okay, BitVM is here, BitVM is ready, then we have this bridge, magical bridge, right? BitVM is simply, it's an optimistic computer. It enables bridges, but it doesn't mean BitVM works as a bridge for all the use cases and the security for all is the same. So we will open source our implementation this month, and it requires much work to like build the bridge actually. So building BitVM is a challenge, but building a bridge around is also another challenge because you have to deal with all these connector outputs. You already had these pre-signatures coming from BitVM, but right now you have more pre-signatures because of connector outputs, and you need to enforce everything into BitVM program. So we had to, let's say, recursively verify everything in a single ZK proof. So the bridge work is also extremely hard to do besides the BitVM implementation, and this will be the second thing I will add.
Wow, there's a lot to sort of digest and summarize there, but I think to recap what you guys said, Eric, you started out talking about sovereign rollups and the fact that actually there've been rollups. In fact, I think the first rollup ever developed and used was Mastercoin, was OmniLayer on top of Bitcoin. But I think at least the way that I see it is that sovereign rollups on top of Bitcoin are not that interesting because a sovereign rollup is essentially just using the DA and consensus aspect of the underlying chain, which Bitcoin does have very secure consensus, but the DA is quite limited, and you're not using at all any like the settlement or tapping into the liquidity or the users in the community underneath. So I think the way that I see it is, the like settled rollups on Bitcoin and the sort of like innovation of BitVM to enable that is what makes these rollups even more sort of compelling. And at least within BitVM, it sounds kind of like it is itself almost like a BitVM instance on Bitcoin. It almost sounds like it is itself an optimistic rollup, essentially. And then, but then within that optimistic rollup with sort of like a limited amount of like you can't run the EVM or anything like very sophisticated in BitVM. So instead, what you do is you would run, for example, Citrea, which could have EVM or some other rollup, and then those rollups then post their proofs to settle into the BitVM rollup or an instance of BitVM on Bitcoin, and so that way you end up sort of having, like you said, this two-way peg, and that will enable like the liquidity and users and community on Bitcoin to sort of have a I don't think it's fully trust minimized at this point, but a less trusted bridge essentially to those rollups. And
Yeah,
I think the fact that a lot of people sort of like, say, oh, well, BitVM collapses to a multi-sig because it's not, it's not a truly optimistic, construction in the sense of optimistic constructions are supposed to be one event. Like anyone, essentially, like it's permissionless to be the person to post a fraud proof or contest the state update, and that's not yet the case in BitVM. So I know that there's probably still, I've heard that there's a lot of work going on in a new version of BitVM, maybe perhaps in development. I also think, as far as I know, there's a few other upgrades that people have been talking about, to Bitcoin. I know that one of them is very close to your heart, Eric, which is OP-CAT, and as far as I understand it, it will enable covenants and different things that might make things like BitVM more trust minimized, or something to that nature. And also, perhaps in the far future, I'd love to talk about the possibility of Bitcoin actually adding a ZK verification opcode to its state machine, because that then would enable native settlement like Citrea. You wouldn't have to go through this sort of like two-step of like, okay, well, we have this other optimistic rollup essentially that we settle to that then settles to Bitcoin. It's like you settle directly in Bitcoin itself. It just seems much cleaner and simpler to deal with. So I'd love to talk about OP-CAT and ZK verification opcodes for Bitcoin, and what you guys see there.
Yeah. So just continuing on from what Orkun said previously, that you don't necessarily like in the BitVM white paper it talks about these NAND gates, but then in the implementation stage, like you don't necessarily need to work with NAND gates. It's more like a way to describe how you can actually reach Turing completeness with a very simple system. So you mentioned these instructions, Orkun, and just since I'm not as involved in, it's sad that we don't have Robin Linus here that's working on the implementation of this, but you guys are obviously working very close and like keeping track of like the latest status of BitVM. These instructions that are more high level, like you mentioned the instructions, but are we talking about like assembly instructions, or are they actually like Bitcoin script instructions, or because these mul and div instructions that you gave reference to, can you like give some color onto like how high level are these instructions, and like is it assembly based, or is it like is there something that we know that they're using, or are they making their own implementation using like BitVM instructions that encapsulate like some primitive instructions for basic arithmetic or something like that?
Yeah, so basically it is very similar to assembly, but they have their own instruction sets. So they are building this BitVM computer, which literally has, it is RISC-V like instruction sets. So what we do is, for example, we compile our ZK verifier into RISC-V, then we transpile it into the BitVM's instruction set. So it is kind of custom computer with fresh new instruction set, but it is very similar to existing instruction sets so that you can easily transpile. And for each of these instructions, there is an on-chain script correspond to the instruction. And once you construct this, while you are constructing this BitVM contract on-chain, you simply get all these instructions and merge these scripts together with, like, let's say, size of 4 megabytes or 1 megabytes, and you embed it into Merkle chunks, Merkle leaves of the taproot tree.
Mm-hmm. Another question that ties into what Nick wants to talk about next. I remember that you actually had the OpCat, you had the OpCat basically in your Twitter name. You had OpCTV and OpCat, and Robin Linus, who's not here unfortunately, has also been gone on multiple like tweeting sprees talking about like how amazing it would be to have OpCat in Bitcoin. Just to explain to the audience, like super simply, what OpCat is. I'm going to do another stupid analogy here and see if it works. Maybe it'll be simpler this time. But imagine that Bitcoin script is like a calculator, and if you look at the calculator, then maybe you've seen like there are some sinus symbols, there's cosine, and there's tan. Like these buttons do different mathematical things, and these things are basically called opcodes in Bitcoin. So and also like there's the regular arithmetic math signs also. You can press 2 and you can press plus and then you press 2 and then your calculator knows what to do. In the case of opcad, it's a very simple opcode that would allow you to take, if you press 2 and then you press 2 again and then you press cat, what it does, it's going to take those two twos and put them together, so now you got the number 22. But it can also do this for strings. So for example, if I say hello, if I type in hello into the calculator, and then I type hello again, and then I press cat, it turns into hello, hello. So this is, I mean, it sounds as simple as like multiplying things or adding things. It actually sounds even more simple because you don't even have to do anything, especially arithmetically on this. Like you're basically just smashing them, you're smashing two things together. You don't have to actually like calculate what is 3 plus 2 or what is 7 plus 5 or do any multiplication. So it's a super simple opcode, but through like the magic of computers, you can do extremely advanced things with this. And one of these things that you can do if you had the ability to squish things together this way, if you know anything about like how Merkle trees are constructed, a Merkle tree is essentially like a tree of hash values, and what you do in a Merkle tree is you squish hashes together, and then you hash that, and then you keep doing that for like an entire. If you imagine 10 items at the lowest level of a tree, and then for each two sets you squish them together and you hash them, and now you have 5 hashes, and you keep squishing them. Sorry, I should have done this with a different number. But if you have an exponent of 2 at your bottom, then you can keep squishing hashes together until you get a single hash that sort of hashes all the value underneath it, and the root of that is called the Merkle root. And a lot of the things that we're doing in Bitcoin is based on Merkle roots, and Ethereum also, like all the accounts and all the states of the Ethereum is also expressed through Merkle trees. And if you have that, you can basically reference a current point of the entire Ethereum network or the Bitcoin network by pointing to like this is the root hash of that block, or this is the root hash of that state in Ethereum. So if you have the ability inside Bitcoin script to like validate such a tree, then a lot of new programmatic paradigms become unlocked. Another thing that you can do is you can basically look at hashes of transactions. So if you squish enough data together inside the Bitcoin script, you can verify that transaction has a specific hash, and then you can, based on that, checking if the hash matches a specific value, then you can allow other outcomes to be true. So this is exactly what is called covenants in Bitcoin, that you constrain the future output of a transaction based on like it needs to look like this other transaction. If you can do that, it unlocks a programmatic paradigm that we call a finite state machine in Bitcoin. So you can create like a small computer inside the Bitcoin scripting language itself that has the ability to keep track of values and variables. So you could get something that starts to look like an Ethereum smart contract, where you have a 1 and then you update it and it turns into a 2 and it turns into a 3. Like right now, you don't have that level of expressivity inside of Bitcoin. But if you had something like opcat or another covenants-related opcode, you could start to get like contracts with state inside of Bitcoin. So this is one of the reasons that we at the Taproot Wizards team, we're super excited about opcat, because it unlocks this. It essentially allows us to create like smart contracts that could be the basis of other layer 2 constructions that are more similar to actually rollups, the way that rollups actually look on Ethereum today.
So yeah, for example, in BitVM, like I talk about the instructions. So simply to put a fraud proof for these instructions, after each instruction, the BitVM program Merkleizes all the states. So it creates a Merkle tree of its state. And after that, you can put a fraud proof, or like you can reveal the leaf by using this Merkle proofs. But with today's Bitcoin script, you simply cannot do that because the inexistence of OP-cat. If you if we had this like OP-cat, then we can simply like concat the two leaves and hash it together and concat with the next leaf, so we can get this Merkle proof working on Bitcoin. And in BitVM, we need this. So basically, BitVM team built a new hash function from scratch, which is called Blake tree. So they built this hash function just to be able to do that, and it's already, I think, costs several hundreds of Bitcoin instructions. So if we had opcat, it will be much more simpler, and this will make the Bitcoin script size smaller and the on-chain footprint smaller as well for fraud proofs. So it is kind of important to have this OP-cat for almost everything. That includes Merkle trees and covenants. This is why mainly I was supporting OP-cat, and I do still support it. Besides that, there is two covenant proposals, which is TX hash and CTV. So they also reduce the number of pre-signed transactions in BitVM setup. So it will also help us to like reduce the off-chain data cost and setup cost in BitVM. So I agree with everything Eric said. We immediately need OP-cat, and I do support both like TXH, CTV. I don't have enough knowledge to like say one is better than the other, but either of them will work and make the BitVM much more efficient.
Yeah. So Nick, sort of answer your question. So I think Orkun explained it great that through Merkle commitments, you can make BitVM like way more efficient. And one of the things that we're talking about here is when you set up these state channels, you remember how sort of like trusted setups were required for some type of zero knowledge cryptography in Ethereum? With BitVM, you have not exactly that, but you also have like a setup phase where the participants in the state channel basically need to share with each other and sign each of them an entire tree of a computation. So you have to like basically take the entire computational tree of the type of computation of the type of circuit that you want to be able to validate. But that involves like building like the entire binary computation. Orkun, you're going to have to help me out with the explanation here. But you have to exchange large quantities of data where you store these bit commitments even before you do anything. So in order for the state channel to even work, you need to exchange large amounts of data. And if you want to update the number of participants or like include another Bitcoin deposit that's supposed to be guarded by this circuit, then you need to do this computation again. So those are large amounts of data that the participants of the state channel will need to exchange before they can do anything. And that is one of the trade-offs of using BitVM as your two-way peg system, because it's sort of constrained by, okay, how much data can we communicate here? How fast can we do that? You can make BitVM a lot more efficient by reducing the amount of data that you need to exchange in the setup phase. But what we're discovering in the sort of Taproot Wizards team is that you can do something with OpCat that looks more like sort of a traditional optimistic rollup using these Merkle commitments outside of BitVM. So you don't necessarily need to use BitVM and the confines of that. You can. There's another property that we discovered recently, and it's the CTO of the Taproot Wizards team. Some of you may have seen him. His name is Rot13 Maxi Randall. He basically started to play around with an old idea from the Blockstream team where you could build a type of covenant construction using CAT. He wanted to explore whether you could build recursive covenants. So basically have transactions that depend on transactions that depend on previous transactions. If you can build that, then you can build this finite state machine that I was talking about. So he was exploring that to build vaults on top of Bitcoin. And in that process, he basically discovered that, like, from this old Blockstream article from 2021 by Andrew Polstra, the inventor of Taproot, he found that you could actually use that idea to create recursive covenants. And if you then combine that with sort of the Merkle commitments from Opcat, you can build something that's even more powerful than BitVM. And we haven't shared the details of what exactly that would look like yet, but it's something that we're probably going to start putting out in front of the technical community pretty soon. Like, we could be talking of the order of weeks instead of months. But it's difficult to sort of talk about it because we haven't really shared how that looks like yet, and we haven't really finalized how we want to describe that system yet. So there might be something new coming out that's like something comparable to BitVM, but more similar to how optimistic rollups work on Ethereum.
Very interesting. It's amazing that such a simple opcode can enable so much. It's like you said, Eric, the kind of the magic of computers, that you can build such complex things off of just very, very minimal building blocks. But one of the things I wanted to ask though is, like, do you guys actually think that, BitVM with OPCat and the new things that enables, is that enough for Bitcoin to be a settlement layer, or should we still push for a ZK verification opcode in Bitcoin, because that, to me, is at least the gold standard in like trust minimized settlement?
Yeah.
Yeah.
So go ahead, Orkun. Sorry.
Yeah, sorry. So yeah, I think OP, ZKP, OP, Stark Verify, whatever it's called, I think it is the like gold standard. We must be there once we like have BIP ready and all the tests done. But there are several blockers on it. So first, like, we need to first decide on a proof system, which is like current, I don't know, maybe hundreds of proof system exits, and every one like independent from us. There is trade-off, like Stark cells are very good, but they are huge. Gross 16 is nice, but it requires trust to set up. So we need to find like common ground that every proof can be wrapped into and represented into Bitcoin. So this is the first blocker, and the second is it is like too broad. So basically, once we have this OPZKP, then we don't need to have any other BIP for opcode changes, because you can build a circuit for CTV, you can build a circuit for CAT or any other thing. So it is great, but it also enables some maybe like attack vectors that we haven't discovered yet. Even though I support this kind of soft fork and BIP, we need to be careful about the implementation and also what it can cause. So I don't think it will happen like in 2 or 3 years. Maybe this year we can see a BIP, hopefully. But BitVM is currently a stepping stone for every team, including us, to have this gold standard.
Yeah, what I was going to say is that I mean, of course, we want like native zero knowledge proof verification on Bitcoin, but there are multiple challenges to that. The first one is that a zero knowledge verification opcode isn't enough on its own in Bitcoin in order to create a ZK rollup. We talked previously about like the need for just the ability to like preserve state, like have a variable that you can update. Like, sure, you can have a Bitcoin script, and then you can have inside that script, like, you need to do a little bit of computation and make sure that the zero knowledge proof equates to valid, and that's all fine. But what are you doing with that unless you're like updating the state of a bridge, and like you're allowing people to unilaterally access out of a bridge? Like, you need to be able to do something that preserves the outputs of the zero knowledge verification. So you need covenants still in combination with a zero knowledge proof verification opcode. So it sort of follows logically that you'd sort of do the easier thing first, which is a covenants, and decide what should that look like. So that's why we're now focused on, like, opcat is a way to enable covenants. Let's see if we can get a covenants opcode activated first, And even covenants are like extremely difficult. Like even just this, I described this previously. Like we're talking about something that squishes two numbers together on like a calculator button. So in the Ethereum world, if you're telling them that, hey, we're really struggling here, like we want to be able to squish two values together in Bitcoin, and this is there's a big social discussion that needs to happen whether or not this is fine, whether this is okay, or whether there are second order effects that harm the Bitcoin protocol from the fact that we can now squish two numbers together. To an Ethereum person that's like thinking about KZG precompile and stuff like that in Ethereum, like, do you want to, they're used to adding so much more complexity to the Ethereum system that to an Ethereum person, it's going to sound ridiculous that we're having this conversation. The other thing with Bitcoin, that even if we had like covenants and even if we had zero knowledge proof verification, the types of covenant that we're likely to get into Bitcoin are going to be severely limited, just because Bitcoiners are so afraid of, like, we don't actually want full rich statefulness on Bitcoin. We want more leaner, elegant tools that are very confined and constrained in terms of what they can do. So it's not so even if we have like a covenants and a zero knowledge proof verification opcode, imagine that you try to build a rollup from that. Maybe you could only build a type of rollup that you can deploy once, and then you can never upgrade the code for that rollup. So what if we, and also keep in mind here that this zero knowledge proof verification opcode that we're putting it into Bitcoin. What exactly is the Z-key circuit that we're using there? What is the VM that Z-key circuit is good at proving? How fast is this prover working, and how competitive is that to other types of them? There's hash-based zero knowledge proof systems, and there's curve-based zero knowledge proof systems, and these two things have different trade-offs. And there's a technical progression on sort of for the hash-based ones. There's technical progressions for the curve-based ones, and it's sort of in flux at the moment. Like which, I work on for the Starknet Foundation. I'm a board member of the Starknet Foundation. I think that I can see a lot of advantages of the hash-based ones, like zero knowledge cryptography. I think that it fits better with. It doesn't have a trusted setup, and it's using very non-exotic cryptographic primitives. So I think that would sort of vibe better with the Bitcoin culture and the Bitcoin community. But at the same time, like, you have this curve-based zero knowledge cryptography that's really popular in Ethereum, and a lot of it is like, maybe you can even zero knowledge prove the EVM faster using that type of cryptography. So how are you going to choose which zero knowledge proof upgrade you're going to pick if it's going to take 3 years to get that activated? How are you going to be sure that 3 years from now that is still the type of circuit that you want to zero knowledge proof? So because you don't have this ability in Bitcoin to, okay, we want to have one zero knowledge proof opcode, and then if we don't like it, we want to use a different one. We can't really, like, we have to sort of pick one and then stick to that. So we are working in a much more constrained environment that just opens up for this endless bike shedding on picking which ones we should have. That's why some of the conversation right now is around, do we just want to find a way to very efficiently prove like a WASM engine inside a Bitcoin, and then we can write a bunch of different zero knowledge proofs in that language, and then zero knowledge proof that. So you basically create like a little microcosmos for creating and validating zero knowledge proofs. Like, maybe that's what we want to do in Bitcoin. Problem then is that you'll have people saying, well, if you have like a KZG, a curve based zero knowledge environment on top of Bitcoin, and then you want to maybe use a hash based zero knowledge proof system to prove that. If you're sort of layering these different zero knowledge proving systems onto each other, you may lose, like, now you still have the trusted setup problem ultimately because you've layered these two constructions on top of each other. So it's not necessarily obvious either that we can sort of layer nestle like zero knowledge systems inside of each other and get the full benefits of that. So I'm more optimistic that we can do something like opcat, and then maybe we can do optimistic verification of different zero knowledge proofs. So if you have a way to do like arbitrary computation that you can do an optimistic resolution of, then you can still access a lot of the zero knowledge proof systems by allowing that to be the thing that you're doing the optimistic verification of. This is basically what BitVM is trying to do. It's all this very dispute resolution. How that becomes most powerful is that if you're doing that on top of zero knowledge proofs, and this is exactly what the Citrea team is doing. It's using the BitVM optimistic verification of zero knowledge proofs, and I think that that's probably going to be a place we're gonna be at in Bitcoin for a long time, like doing optimistic verification of zero knowledge proofs rather than like finding one silver bullet zero knowledge proof verification opcode and soft forking that into Bitcoin.
Yeah, there's a lot of reason to be cautious, and I think actually the Bitcoin community has done a great job in stewarding the protocol and keeping it very minimal. And what's so exciting about BitVM and also I guess adding a ZK verification opcode is it's like the minimal amount like change that you can the minimal amount of functionality that enables like the most amount of things that you can build on top of Bitcoin. And so I think there's actually a lot of similarities to that sort of philosophy in the Celestia community, where we also we want to keep the state minimal. We want to keep the chain, the protocol as minimal as possible. And there's no kind of coincidence that I think Celestia is also exploring a CIP that would add so-called ZK accounts, which is sort of the same idea as ZK opcodes for the Celestia state machine. So there's a lot of connection there, and maybe depending, I think Celestia can obviously be a little bit more aggressive than Bitcoin being much earlier. Maybe there's some lessons after we've implemented that could help inform what Bitcoin does. I think that would be really cool. We're coming up in the last 10 minutes of the space, and so I wanted to ask a few more sort of high-level questions, which is that and so it sounds like we're all aligned. Everyone's very excited about adding settlement to Bitcoin, but the other thing that's necessary for rollups is data availability. We haven't really touched on that yet. I'm curious, Eric, you said earlier in the space that the Bitcoin community has always said, they want to keep the blocks small so that people can run nodes and verify the chain using a very minimal machine, and that they want to preserve the history of the chain. You don't want to embrace pruning, which both Ethereum and Celestia will embrace. So I'm curious if you like what do you think happens for Bitcoin? Does it just become a settle? Like what is its role ultimately in the modular stack? Is it purely as settlement? Do people maybe still use it for DA and consensus, or do you think that off-chain DA solutions like Celestia, for example, would be necessary for scaling and securing Bitcoin rollups in the future?
So I actually do have an answer to that, and I'm gonna tease you with something, Nick. I'm gonna leave you with a bomb here.
Tease me, Eric.
So if you wanna like buzzwordify this, the thing that opcat allows, it essentially allows for Bitcoin to go modular, because if you get this Merkle verification, then you can combine this Merkle verification with a bunch of different DA layers. Because what you do in optimistic rollups, right? You have state commitments. You have state updates that commit to a state in a type of Merkle root update, and then you prove that between this Merkle root and that Merkle root there was an invalid state transition. And that is that type of like being able to do a fraud proof between two Merkle states. That is the sort of ingredient that allowed Ethereum to become modular. Like that is why we have a bunch of different, execution environments in Ethereum, as long as you can validity prove or fraud prove that execution. And with Opcat, we're going to be able to do that on Bitcoin. And so it's going to open up this modular paradigm for Bitcoin also. So that is very exciting. And then to sort of answer your question, what I was talking about, like for ordinals, and that the provenance is extremely important, like seeing exactly who owned what, that is very important for this very niche use case of Bitcoin, where you have this NFT ecosystem, and people are caring a lot about like which are the different owners that have held this particular NFT. But if you wanted to build something that's more like commercially useful, like actually scaling Bitcoin, if you wanted to build like a high throughput second layer system that doesn't just process a couple of hundred transactions of Bitcoin transfers, or also if you want to like tap into expressiveness and do matching engines or automated market makers or something like that, you're gonna need more DA. Yeah, I mean, I think that sovereign rollups on Bitcoin today that actually use the Bitcoin DA, that is going to be useful for in the medium term. That's going to be useful only for like this very niche ordinals focused use case. But if you want to build actual like scalable systems for the future, and like giving Bitcoin the ability to become like a micropayments asset, then a Validium is a pretty interesting place on the trade-off spectrum, right? So if you have a Validium or actually a Celestium, for example, would be even more interesting here. You could have a zero knowledge proof system that uses, and I'm talking now about like optimistically verified zero knowledge proof system, so it wouldn't be real Validiums on Bitcoin, but you can build a type of Celestium on top of Bitcoin where the DA is on Celestia, and then you do like fraud proofs over on the Bitcoin side. That is a system that has an interesting spot on the trade-off spectrum and could reach like gigantic channel-free scaling for Bitcoin in a type of layer two. So I think that definitely we're gonna explore all the variants of this in the Bitcoin ecosystem as well. But in my mind, like maybe you can do this with BitVM, but I'm more personally excited about like what we're going to be able to do if we get Opcat activated.
Orkun, how do you guys at Citrea think about data availability?
Yeah, so like Bitcoin DA is, yes, quite limited, but it is the only option that gives you full Bitcoin security. So in that sense, like BitVM bridges, even though it's like huge improvement over existing multi-sig solutions, it is quite inefficient in bridging. So like you have to have this fixed UTXO size, and like there's like some limitations and pre-signatures. So I think that there won't be like many L2s that use this kind of BitVM bridge, because it is costly to operate and not that efficient. So I think having a Celestium using BitVM bridge might not be that feasible, because with BitVM we introduced this honest minority assumption, but then with blob stream we kind of get this honest majority assumption. So even though Celestia protects the data with its like own social consensus and token, once you relay the data, I think it's like not honest minority anymore. In like Celestia, it becomes honest majority because of the signers of the blob stream. So I don't think it is not very like uh, usable for every use case like L2, but I think for L3s and like custom execution environments and like custom niche applications, yeah, I think integrating alt DA layers like Celestia will enable these L3s to achieve huge TPS with using this trust minimized BTC.
Beautiful. Do you guys? We're at almost at the end of the time. Do you guys have any closing thoughts? One thing that just like sticks out to me is just I always kind of come back to Satoshi, who's sort of the godfather of all of blockchain. And I know that, for example, I know that the Bitcoin community often refers back to his opinion and what he said in the limited amount of sort of like communications that we have, records, although there were a bunch of new emails released recently. And I know that, like, for example, he was almost included opcat, for example, but then he removed it because he was afraid of increasing the attack surface. But that makes, I think, introducing opcat a little bit easier from a community perspective. But in the Bitcoin white paper itself, interestingly, Satoshi makes a reference to this idea of alerts, which are essentially sort of like a very similar construction to a fraud proof. And so anyway, I just, and he always made a big emphasis on SPVs and end users being able to verify things. And so I feel like if Satoshi would be, if he could communicate with us, or they could communicate with us, they would be in favor of modularity. I just get that feeling. I wonder if you guys, what your guys' opinion of that is. Like, what is your read on what Satoshi's opinion of all this stuff would be?
This is sacrilege, Nick. I can't put words into a dead god. But I will say that there was this. Satoshi has a lot of writings around that actually like favor the big blocker position in many cases, where he's talked about that Bitcoin never really hits a scaling limit and you can always just increase the block size. A lot of those arguments sound similar to what big blockers say, but I think that he made a lot of those points before it was very clear to him that this fraud-proof flagging mechanism, alert mechanism that he had described in the white paper didn't really work in practice. So like fraud-proof was like this thing that we thought in Bitcoin was going to be easy initially, and then the types of SPV proofs that were ultimately built were didn't give you sort of that fraud-proof mechanism. So like in a world where you actually have fraud proofs, I think that is a world that allows you to do things like increasing the block size more under reasonable security assumptions. So I definitely think like getting fraud proofs working on top of Bitcoin through BitVM or Opcat or something like that, it opens up for processing large amounts of data, as long as the only thing that you have to validate is like a fraud proof in order to have a reasonable security model. So definitely like fraud proofs usher us into this world that Satoshi envisioned, where you could have large blocks without a complete degradation of the security model.
Yeah, so if I say like yes to Satoshi, Will Satoshi like said, modularity is the way, I will feel like a little bit maxi. So I wouldn't say that, but yeah, the alert thing is definitely, it refers to fraud proofs like Celestia does today, which is like incorrect encoding fraud proofs and such. And also he or she multiple times mentions that like ZK proofs should be used for like compressed blockchain data, and like there can be other chains which share full GPU CPU power of Bitcoin. So this is like kind of describing ZK rollups, where you do all the execution, but eventually all of the execution is secured by Bitcoin thanks to this succint proof, and it uses full CPU security of Bitcoin with little overhead. So I think this kind of execution delegation or execution sharding, he or she will be favoring that.
Fantastic. Well, guys, we this has been an amazing conversation. I think we've covered a lot. I learned a lot about BitVM and just how Bitcoin intersects with modularity and what we can expect going forward. I'm really excited about all the innovation going on, and I'm hoping that Celestia can also play a role in helping to scale DA for Bitcoin rollups. Feel free to share any closing thoughts, and then I think we can end the space.
No, I just I think it was unfortunate that Robin Linus wasn't here, and I had to torture everyone with with my Black and Pebble description of how BitVM works. That's sort of where I'm stuck still mentally.
Yeah,
Oh well, you did a really good job. Go ahead, Orkun.
yeah. Like, thank you for having me. I think it was like both technical and cultural, inspiring speech. Thank you everyone for joining.
Thanks everybody for joining. Thank you, Eric and Orkun, for enlightening us. I think there's a lot to look forward to in the Bitcoin space around modularity, and I'm hoping that we'll have more conversations like this. So thanks everyone, and we'll see you soon.